Morning, everyone. Respected chairman, today's chief guest speaker, C.A.PRASAD, and the participants. A very warm welcome to all on behalf of HCA. My name is Prasad, Secretary of HCA Kakinada Center. We are grateful to Mrs. Anja Prasad, Director, METEY Engineering Private Limited, President of HCA Hyderabad, accepting our request to deliver today's lecture. Housing as an industry is still handcrafted and heavily dependent on manual labor and on-site work, which leads to large amount of material wastage, labor intensity, and delay in project delivery. Precast construction technology is a quality and time-saving method. Precast technology promises world of creative possibilities in application design. Today's topic, precast construction technology for the delivery of structures. By engineers Anja Prasad will give us clear idea about precast systems, precast abroad, precast projects in India, precast industries in India, types of precast systems, precast concrete structural elements, precast composite slabs, precast and cast steel slabs. Very informative presentation. Hope the presentation will be completed in 1 hour and 15 minutes will be question and answers. Request participants to utilize this opportunity. I welcome Chairman of the Center, Engineer Garu, to address the webinar and introduce today's chief guest and speaker. Thank you.
Good morning to all. It's a great privilege to me to welcome Sri Anja Prasad as a speaker for today's webinar. He is a very well experienced civil engineer having expertise in precast construction and shear wall technology also. It's a great privilege to me to introduce him, and as a part of our regular activity, every month we are conducting the webinars, and it's a part of it. And we are continuously, since our inception of Kakinada Center, continuously every month we are conducting webinar and with the experts of the field for the benefit of civil engineers. As a part of that, today's program is on precast construction methodology and its applications. Sri C.A.PRASAD, Director, METEY Engineering Consultancy Private Limited and President of PSA Hyderabad. He is a good friend to me, and he is a product of Kakinada. We are very proud to have C.A.PRASAD in such a good position at Hyderabad. He got so many works of his credit. Mr. Prasad is an engineering graduate from JNTU Hyderabad in the year 1982 and is a postgraduate in engineering structures, MTech from REC Warangal, that is previously it is Kakatiya University, in the year 1989. He has more than 40 years of experience to his credit in the various fields of civil engineering. He has worked in the Middle East for more than 10 years and has returned to India in the year 2005 and has set up a firm called PS Engineering Consultants and later migrated into METEY Engineering and Consultancy Services Private Limited and is delivering consulting service in India. His experience includes structural design of multi-storied structures project management of works, supervision and execution of works. He is a well-known personality in the field of precast and prefab works and is encouraging and promoting precast and prefabricated structures in India by advising and assisting the developers in the setup of precast factories and delivering precast and prefab consultancy services to them, and presently the president of Pre-Engineered Structures Society of India, PSI. Actually, under the guidance of our Prasad, one precast unit is coming up at Pedapuram near Sorampalem. That project is that precast manufacturing unit is coming up at Pedapuram, that is at Sorampalem, is under the guidance of Sri C.A.PRASAD. He is a member of Board of Studies of various engineering colleges in AP and Telangana states. He encourages students and accommodates them for internship by imparting training in his design office, which is part of institution's curriculum. He is a fellow of Institution of Engineers India. He is a chartered engineer of India. He is a member of American Society of Civil Engineers USA, chartered member of Structural Engineering Institute USA, fellow of Association of Consulting Civil Engineers India, and founder secretary of Pre-Engineered Structures Society of India, PSI, and presently its president. He is a member advisory committee of ACCI Hyderabad Center. It's a great privilege to welcome him. I welcome Sri Prasad Garu, sir. Please continue the lecture, sir.
Thank you, Badam Sundara Garu, for your introduction, as well as Durga Prasad, and welcome all the. Are you able to see my this thing?
Yes, sir. Yes, sir.
All right. So the topic today is the prefabricated construction for speedy delivery of structures. Right, to start, and hopefully it will be interesting to you. This new technology, I will not be boring. Okay, it should be interesting, and we will look at it how we will proceed with that. Look at the cast and screw system. In a cast and screw system, in a multi-story construction, you can see. Are you able to hear my voice?
Yes,
All of you?
Yes, sir.
Yes, sir. It's very clear, sir.
Okay.
Very clear.
So my presentation is also visible.
Yes,
Yes,
sir.
sir.
It is visible.
Right. Okay. Right. So now let us look at the cast and screw system. You can see a lot of congestion in the multi-story buildings where a lot of formwork is there all around. Okay. And with this congestion to construct and all, and especially when you are erecting there now, in this photo, what you are seeing there is only the column structure. When once the beams and slabs, it is pretty difficult to walk around and do all this. Right. And in the conventional construction, most of the part is the formwork plays a bigger role. Formwork for column, formwork for beams, and heavy shuttering and scaffolding works and supports. Okay, and when there is a big podium and all, yes, you need to have about 9 to 10 meters, 6 to 10 meters like these podium structures, and a very heavy shuttering comes into play of how to support it. Even sometimes you provide a steel beams over some entry portions and then support this and all. But when you look at a precast system, now all these elements comes from the factory, okay, where there are wall panels with openings and all, and you don't see any congestion at all. The elements are directly coming there, you hardly see any labor into the system also. This is the beauty in the precast construction, right? Now we look at the precast abroad. Okay, precast abroad, especially in America or Middle East, Europe, and everywhere, where they are constructing this. Even facade panels are also built using the precast elements. Okay, and then you can see that colored facade panel that is also made of a colored pigment. They add a pigment into the concrete, and they get a beautiful color of whatever they want. Yes, we are doing this now in India also, but people are also doing this. That's a good sign. So in the buildings, see what happens is I have been in the Middle East starting from 1995 to about 2005 for about 10 years. When I went there in 1995, there are only three precast companies. And by the time 2000, about 10 precast companies have come. By the time 2015, there are about 20 precast companies. And still they are insufficient for the big development and the growth that has taken place in Dubai and the entire Middle East. This is how you can see that mushrooming of the towers and all, they're all built predominantly using the precast structures, and some structures are even built castings too, because the precast factories are not able to meet the demand. Okay, that is how this thing has come. Even looking at the conventional construction, I was looking at in 1995, a 30-story structure was taking about 5 years time. By the time 2000 has homework that we have on the construction technology. But by the time 2000, even a 60-story structure is taking only 2.5 years time to build. Only the 60 structure is taking a time of only 2 years to build. So there is a beauty with the precast construction as well as conventional construction also, because the formwork rapid changes have come. Okay, rapid changes have come in formwork also. So sometimes it is partly conventional and the precast mixed of the things also goes into these structures. Okay, especially when you are talking about the lift core walls and all that, still they will go with the conventional form, whereby the slip form technology, jump form technology are used for the construction of these lift core structures around, such that they go faster than the structure with which you are going to build with a precast or a conventional form of construction. In the type of structure that are coming up in India, we look at some of the precast projects in India. Now this is Omkar in Mumbai. What the government has provided in Mumbai is in the slum rehabilitation areas, they have first of all build the structure, whoever the people are being displaced, they have to build a structure first of all, and then for the remaining area, they can develop what they want. So with the result, L&T have taken up this particular building to be built in about 20-story structure to be built in 1 year time, such that all these slum people can be accommodated into this building. Thereafter, they can construct the building. So in order to do a 20-story structure, so far, precast is the only answer. So they have set up a precast unit there itself, and then they built this particular structure within no time. There is a beauty. So in this structure, what they have also done here is, they have even made the toilets as a box-like structure with the door opening, such that there are no leakages. Toilets are the hell of the thing whereby the leakages and everything will happen. So they have made the box-like structure, brought it and then put it into the structure. Thereafter, you can see some load-bearing precast walls, precast chains, and then some hollow core slabs will come on top of them, which is a very simple way of construction. That's how they have done as much precast as possible, such that it goes in. There is no in situ construction at all in this structure when they are thinking of it. Some CTS Canteen Pune is a precast structure. Santushti Homes at Bhiwadi is a 250 affordable home, G plus 3-story blocks, again with a load-bearing precast wall and hollow core slab section. Okay. So this is how these buildings have come up, and the load-bearing precast walls will be coming on the trucks, and then the tower crane will lift it and place it one over the other, and it will have the dowels from the walls, such that one wall will come over the other, and then they will grout it. I'll show you some more details as we proceed. Wow. Even Lakeside at Chennai is being designed by one of my friends, Saurabh Purandare. Okay, a precast designer. He does only precast designs, whereas I do both. He does only precast designs. He's a wonderful designer from Pune. He has also designed some 16-story Pina project for Tata at Bangalore also. Okay, so it is. We can see that is again load-bearing precast walls and hollow post line. Now I have been talking about load-bearing precast wall. I'm not talking about precast columns and beams. Right. The beauty and advantage with load-bearing precast walls is that in the case of an RC frame, if you are constructing a column in the beam and on top of that hollow core slab is building, you have the flexibility to build the wall again inside with AAC block wall or brick wall. But in a load-bearing precast wall, when you are doing the hollow core slab will come and rest on the wall, then it is like a uniformly distributed load for every millimeter of the space on the wall. It's something like that's why we call it as a load-bearing wall. For every millimeter of the portion of the wall, there is a slab load coming on top of that and uniformly distributed on it. When you are providing a load-bearing precast wall, there is no column and beams required. No columns and beams are required. It is directly an element which is eliminating everything. In the RC frame construction, you have columns, beams, and then an infill wall. Now all these three are eliminated. Only a wall is coming in place of it, okay, which is a concrete wall. There is no plastering required thereafter. A slab is placed directly on top of that. Okay, and then a structural topping is done. I will talk about structural topping a little later. Now, C.A.PRASAD was the first developer in Hyderabad, whereby they have taken up the precast. So at that time, they have involved us to do this particular design. So they are all precast walls with the openings and all. You can see some dowels coming out. So what they will do is the dowels are coming out from the foundation. They ensure to see that they go into the sleeves. These are the sleeves which are provided 60 mm sleeves. This dowel from the foundation will go directly into that. Thereafter, we'll ground that particular portion, and then it will be in the position correctly. Right? So at that time, the gentleman has not taken the precast hollow core slab because he has a fear in 2005, 2010 when they have taken up this, that the hollow core slab will be accepted by the customers or not because there is a hollow inside. So we have gone with a PT slab for this building, but with load-bearing precast walls. Load-bearing precast walls, but with a PT slab. That's how we have gone up with it. Yes, you can make the wall of whatever be the elevation type that you want with the openings and all that. Elements can come and directly get erected over there. That's good. Elements are coming up. But in the same compound, those are villas. C.A.PRASAD have taken a call that yes, let them deliver a building within 1 year instead of making the people wait for 3 years and then pay the loan rent to their bank. So they have also done a 10-story structure in the same compound of about 4 towers, which they have made. In each floor, they are getting about 10 apartments using the load-bearing precast walls, but with a cast-in-situ slab is what they have done. Okay, and then this is a 10-story precast structure, and exactly they have delivered within 1 year period. Okay, and then the customers are also happy of booking it within 1 year. They are getting the building instead of waiting for 3-year long period, which the developers usually will take. Thereafter, BDA Bangalore have also done, Bangalore Development Authority have also done using some Gauri precast at Alur, Bangalore, where they have done a different type of construction. They do the independent walls here, and then they connect all the walls together with a bottom slab, and then the walls are all connected. Everything is finished at the bottom level, including painting, doors, even the kitchen tiles and everything with those. This they will lift it and then bring it over here to on the rails to the end, put it on a truck. This will go on the place one over the other on the top. Like this, the 4-story towers that they have built with a quite good number of structures, okay, with ease. So thereby there is no one required to go to the top and then again do some finishes. So it's a bottom slab, walls are connected, everything together, painting, everything is done, finishes, and then this is lifted and placed one over that. That's how this construction went on. So 2 types I have just shown it. One is C.A.PRASAD developers, other is BDAs. Now we look at the precast industries. There are a number of precast industries have come up now in India. Okay, in Hyderabad, if you look at C.A.PRASAD developers have set up for their own use the battery mount, and then Prika is a factory which is delivering structures to industry, both for the building sector as well as for the pharma and industrial sector. And Skill Promoter is again they have built one huge shopping mall at Kondapur near the high-tech city. Kondapur near the high-tech city. They have built one hollow core slab unit within the factory itself, and they have built a wonderful commercial complex over there. Inventa Hyderabad, Inventa have now setting up. Have already set up at Hyderabad as well as at Kisara Vijayawada, and then they are setting up at Pedapuram. That's what Baldam Sundara is talking about. It is not Rajahmundry as what I have shown here. It is at Pedapuram. They are also setting up such that the Pedapuram unit will take care of that Vizag, Kakinada, and Rajahmundry, all other units, whereby wherever we set up a precast industry, it is like it should have a 40 to 80 kilometers range, not more than that, because beyond that, the transportation costs increase. Okay, so that they are setting up one unit over there, which will meet the requirements of Vizag, Rajahmundry, and their surrounding places. PSP Precast is another firm which is set up at Sadasupet, Hyderabad. They have also built two towers in Hyderabad for the GHMC Dundigal. Inventa have also built in the same place for about 9 towers. Okay, and Eco Precast have also done 2 towers, 3 towers for GHMC Dundigal. Right? And then the Precast Buildcon are doing it a small way, but they are also supplying the equipment required for the industry in terms of cables and other things, Precast Buildcon. So Hyderabad is now very well set up, and then there is one more factory which has come is a Teenage Precast, which has come very near to Nalgonda. Teenage is basically from Coimbatore. Now they are branching out. They have set up one in Nalgonda. From Coimbatore, they are meeting the requirements of even Chennai as well as Bangalore also. They have set up a big factory in Nalgonda. They are also meeting the requirements of Hyderabad. Inventa have also set up in Bhubaneswar. Okay, Bhubaneswar, and then they are doing a big project for Bhubaneswar housing development. In Raipur, BSBK have done, and then they have done a very big project for the Chhattisgarh Housing Board. Okay, developing a big precast buildings over. Okay. And then we have Calicut recommend how done it to a particular company. In Chennai, BME Precast is one wonderful precast firm where they have delivered structures for DRDO and other commercial structures also for DRDO, and one they have built one big hotel project in Chennai. In Pune, Precast India Infrastructure, my friend Mr. Ajay Bhate is there. He is doing one study. He's a very passionate civil engineer who have set up this precast factory in a very big way and then doing wonderful structures. I shall show some of the structures we built. And then there is Best Eye Precast, and then I built in Pune or also set up into that. In Mumbai, L&T have set up one for the purpose of a particular structure, and then they removed it, but they have delivered the structures. In Bangalore, as I said, Gauri Infrastructure, and Shaboji Palaji Constructions have set up for Tata Pina project in Bangalore, and a site-based precast project. After it is completed, they have removed that particular facility. Kakinada is there in Bangalore. Okay, they have set up in a huge manner. They are meeting the requirements, and then they are doing wonderful structures. In Noida, Supertech is in the entire NCR region. I could see only one full-fledged precast firm, which is Supertech. Now they are also delivering the steel plus 8-story towers for DRDO, which are being designed by our firm METEY. Okay, and then BJ Shirke have done wonderful structure for Delhi Development Authority. BJ Shirke has a very different technology in terms of they make a hollow portion precast column, and then they pour concrete on the side. Even for beams, they get one channel in the type a U shape type, such that they put the reinforcement thereafter, and then they pour concrete into that. It's a different technology which they use, but is also doing well. Structures are well tested and proven by even IIT Chennai and all. They have checked it and found it to be very good. Bharat City developers in Ghaziabad, they built one 30-story towers and 16-story towers like this in the NCR region, which is a earthquake zone 4. They're wonderful structure. I will show you some of the properties. Now, types of precast frames are such that the precast columns and the beams initially are the hollow core slab. Later on, and the structural elements are like it can be a pre-stressed precast solid flat slab. It can be hollow core slab. Hollow core. I shall come back to this in detail. What is hollow core? Why we are making a hollow core? Then there is a single T slab, double T slab. Single T slab, double T slabs are predominantly used for car parking structures, large span structures, whereby you can even in the shopping malls where they want a large column for these space structures. Right? And hollow core slab can span up to a maximum span of 15 meters, and the thickness increases as you increase the span. It starts with 150 and it keeps on increasing. Precast beams and girders are RCC precast beams and girders. These girders are predominantly used in beams, as you might have seen. In the buildings, we use these inverted T beams and L beams and even the rectangular beams. Okay. Precast columns are such that, yes, now in the conventional construction, what happens is because of the formwork and other things, we construct a column up to one floor and then put up a formwork for the beam and the slab and then cast it, and thereafter next floor column like that. In the precast, it so happens if you can lift a 3-story column or a 5-story column, yes, you can construct a 5-story column at one stretch, okay, and then erect it such that you need not do it for every floor. That is one beauty that we have done even in Hyderabad also. In this structure that I am showing, you can see a 2.5-story precast column. Thereafter, it is a 3-story precast column. So by doing so, you are going to save time in terms of its erection as well as transportation, the ultimate saving in time. You can see that the 2.5-story column as well as 3-story column are joined together, okay, and then they pour concrete at this edge. You can also see that in the 3-story or any column which is there built, then the concrete is left over at the junction with where the beam reinforcement is going to come. Okay, where the beam reinforcement is going to come. Beam reinforcement enters into that junction, and then they pour concrete into that junction, and then you have a corbel to make the beam to sit on this corbel. To make the beam to sit on this corbel, you can see at the bottom also, beam is sitting on that, and then a double T slab is sitting on the beam like this. Okay, so this is how the construction will go on to make it faster. Other post slabs are such that, yeah, it can be simply erected with this is a lifting arrangement with a bracket. You can erect it over the brick masonry walls or a RC column frame or a load bearing precast wall, whatever the way you want. Right? And there is a shopping mall in which we have used hollow core slab as a ducting system, because there are hollows inside. Yeah, you can make the air to circulate around, and then to make a hole wherever you want, it will circulate the air inside. By doing so, the shopping mall was saving about 40% of the air conditioning bill. Why? Because they will try to cool the structure a lot in the night time itself, such that in the daytime it won't take much consumption of the power. This is one of the facilities that hollow core slab can be used, but it has to be used in a proper way to be designed for the particular system. And this is how we have used it for a shopping mall into the structure. To the hollow core slab, again, yeah, you can fix anything, yeah, any electrical conduits or fans or pipes or anything into that, not an issue. Some of these corruptions are there. I don't emphasize much into that, just for information purpose. The load bearing precast wall, 2 hollow core slabs can come. At the junction, we put one more bar for continuity purpose. We pour the concrete. Over a steel beam also, hollow core slab can sit, or in a solid precast slab can sit, and a load bearing wall also you can make the hollow core slab sit. This is one of the reasons. Now, another system of slab is that is called as a pre-structured composite slab. You have just about 50 to 60 mm of concrete at the bottom, and then there are then there are concrete webs will be coming out with the shear loops coming out. Pre-stressing stands are provided here. All this is a polystyrene, and then on the top we provide a 75 thicker structural top. That means it is something like the similar to hollow core slab. There is a polystyrene put up there. This is structural topping is provided on the after erecting the slab on the top. You have a pre-stressing stands here. These are shear loops which are given for continuity and connection purpose between the top and the bottom slab, such that it acts as one monolithic particular slab. Okay, so this is also one technology which is coined by Emirates Precast Construction in Abu Dhabi and Dubai, whereby this system is also used extensively. It can be done placed over the steel beams and precast over load bearing walls and the car. Now the beauty with double slab or single slab is the depth of the beam. These are the beams which will go there, which will be for a span of about 125 to 150. Depth will keep on varying to about 400 to 900, depending upon the span. Yeah, you can have a double T slab for a span of even 30 meters also. But then what is the width of the slab? Width of the slab varies from 2,400 to even 3,000, even 3,600, the way we want. Pre-stressing tendons are kept here, and then initially only 50 mm thick concrete will be placed over there on the top. Thereafter, of placing number of units side by side, they will do one more structural copying as a connection to all the units, whereby it creates a diaphragm action, and then continuity comes into the network. Okay, these double T slabs are such that it has a beauty in terms of large column free space. I'll show you one of the figure photos whereby you will be amazed to look into that. Now you see in abroad with the double T slabs, okay, long trucks are placed there for 30-meter long, 40-meter long. The elements are going on the track. Now we have used this double T spans. Precast has delivered this for the Niger Club in Hyderabad for the car parking purpose. They have also done well. The structure is standing fantastic. So this also, and even the Precast India infrastructure in Pune also, they have delivered the double T spans of the flooring structure for shopping malls as well as for car parking structures. They are doing pretty well. So now you just see this. So I was just telling about double T slabs. You can see that there is a groove, double T slab with a hanging slab on the side. Now, there is a column here, spacing is about 10 meters. But then the double T slab is spanning about 30 meters. That means at every 10 meters in one row you have a column, but for the next 30 meters there is no column. From this column to this column, there's a gap of 30 meters. So now, for a shopping mall fellow, he has this wonderful facility in terms of racks that they provide in the shopping mall. They can provide wherever they want because it's a large column free space. Large column free space. That is a beauty with these double T slabs, and then the columns are coming at one with precast beam and at the spanning of 10 meters, which are going there. Right? So there's one advantage. In now all these systems that I have shown involves pre-stressing whites, pre-stressing stands. Without that also we can do one more this thing in terms of this particular slab which can be done castings only precast without pre-stressing stands. Yes, this is called as a lattice type of system where you can cast only 50 to 75 of bottom, and after placing it on top of the beams, you can pour the rest of the concrete. Whereby from the bottom concrete already cast in, the top concrete, this lattice type system will be the bridge between the two, thereby the slab will be monolithic and do that. So this is how it is. You can see that it's about some 75 to 100 mm thick concrete and a length of about 10 to 12 meters. Okay, they have provided some holes where the columns are coming such that it goes through the columns and then the structure is done. And then, but there is no pre-stressing into that. Okay, and then the thickness may be required 200 or 250, whatever is required, they will place it. So what is the advantage? Without using the pre-stressing system, I'm trying to see that it is just simply a cast and screw system only. But then I'm trying to avoid, I'm just providing only the beams, there is no plywood, because only a 75 to 100 of the concrete at the bottom. Rest of the concrete that is required, I'll be providing it on the site itself. So what is that I'm trying to achieve in this? I'm avoiding my plywood, which will consume a lot of things into that. But since it is an element of only about 75 to 100, it requires to be supported at a span of 2 to 3 meters to take the additional load of concrete that we are going to pour. Thereafter, yes, it will go into its own system of resting on the beam till it gets hardened. Okay, thereby we are able to avoid lot of plywood and lot of beams in other directions. This is one system anyone can adopt at their level using the tables into that. Now this is how the particular systems when it is placed, and on top of that they pour the concrete. Precast stains is a beauty, okay, because in the conventional construction it is so much cumbersome to provide the formwork to the states. So here, what happens is vertically they just put up they mold horizontal length, whatever the particular length into that, and then they just pour concrete of that width of the stair of about 1 meter height into that. That's the beauty into the precast. Then we have these precast walls. Yeah, facade walls are a beauty. Yeah, curved walls are anything. You make a formwork with a steel shuttering and pour concrete into that. And they added one pigment, one colored pigment into the concrete. Here they are used in some white cement, and then they use the pigment, and then they have got a beautiful pinkish color this thing. By doing so, it's a natural color which will sustain there, and there is no need to do painting or anything thereafter. It's a lifelong structure free from paint and other maintenance. That's a beauty which you can do here. We'll just see some of the buildings, I don't know how many of you have seen this particular building. The last time the Chief Minister Chandrababu Naidu was visiting Kakinada, then the local MLA have said that one precast building is to be built here within a week. Okay, so we had this precast wall panels already was ready readily available at Vijayawada. So that's we just sent there, and within 3 days we just built the foundation, raised the wall up to the plinth level. Okay, and then we built this 4 walls. There are just 4 walls all around. Okay, and then on top of that we have provided a hollow core slab. Okay, on top of that, because the 4 walls which are already there, the openings and everything. Internally, they have provided some more walls with the AAC walls, and then on top of it, hollow core slab, you can see that. And then they are building a bit of a parapet wall like this thing, and then the building is ready within 1 week. Where is this building in Kakinada? It is there on the beach road. Okay, it was built already somewhere around 2017 or 18, if I remember. We sent this building, okay, with the wall panel that are readily available at Vijayawada, and then the building is totally built in 1 week. Okay, so this is a 300 square feet building, okay, with one hall and one bedroom and one kitchen and with a toilet facility into that. So this is how this is a beauty of precast building which is built within 1 week in your own Kakinada. Now, Pune is a built-up area of 16.5 lakh as a total number of basement plus poem plus stand for. Precast India infrastructure in Pune have built this building. And BDA project, again, they built plus basement plus steel plus 18 floor building. And in Bangalore, they have built this particular BJ they have built this. In Hyderabad, Preca has built this building. Okay, steel plus two numbers of stills for car parking purpose plus ground plus core structure 1,50,000 SFT. They just delivered in 4.5 months. They just delivered in 4.5 months. That's the beauty of precast where you can deliver in 4.5 months. So that means the main structure on the facade and all that it took its own time. I'm not talking about that, but main the RCC structure is built in 4.5 months. Even G+4 Preca has built this for a hospital building. It has just built in 4 months of contract 20,000 SFT. So they have also built one, the Preca also built on top of a steel frame, they have put up the precast slabs. Okay, for Cadbury project, 2 lakh, they have just delivered in 5 months. Okay, these are the BME group in Chennai. They built this DRDO CAPS hangar building in Bangalore. Okay, from Chennai, they have shifted all the material up to Bangalore and then they have built it there. Okay, and they also built Novotel IB's Combo Hotel in Chennai. Okay, this is all the precast building, and when completed, it looks like this. Right, and the Shivraj Motors, Shivraj Motors are also built by BME Chennai. Chennai Silk Showroom. Okay, Tirunelveli is again built by BME. Office building Gindi in Chennai is built by BME Precast. This is Lakeside Chennai. Again, this is built. This is designed by my friend Saurabh Purandare. Okay, Teammate Coimbatore is also doing well. As I said, they have built one canteen block in just about 38 days. This is about 13,500 SFT. They just built it in about 38 days. Okay, there are beams, columns, hollow core slab, wall panels, and everything. You can see that. And Rotary School, Tirupur, Tamil Nadu, they just built this building in 28 days. Okay, they just wanted a building. Yeah, we want to run a school. But then, before building this building, yeah, we require time to make the elements. Maybe the precast industry will take 1 or 2 months to make all these elements. The design process goes on. But after coming to the site, it just took only 28 days. That's what I'm trying to emphasize. In the site, it just took 28 days to complete. So again, SCM Silk, okay, Tirupur, Tamil Nadu, they're also teenagers have built this building in about 30 days time, 52,300 SFT. Again, Christian Medical College, Vellore, Tamil Nadu, they built a building in 27 days, 50,000 SFT. Right? And then these are the industrial structures again, number of structures where they have built one. You can see the 3-story precast house which they have built for the structure. The Novotel IPC we have already seen it, and then TVS Motor they have used the PEB building steel structure, but on top of that they use the hollow core slab, is deck slab and all. So you can see this hollow core slab, but on the top again it is a roofing structure. It can be composite structure like that. It not be everything concrete. Okay, steel precast hollow core slab a composite structure. Now this is what I was talking about. the structure in HCR region. In the HCR region, Bharat City developers have adopted this particular one structure, and they have built a 16-story and 30-story towers. My Bob is my good friend. Okay, who is from abroad, Europe. He has designed these particular buildings. Okay, with all the load-bearing precast walls and all. Okay, so the elements are built there using this particular structure. And when it is getting completed with the paints and everything applied on them, it looks so beautiful there like that. Okay, this is how the particular wall frame execution is. Now, Precast India infrastructure, what I'm talking about, they built this beautiful building. Mr. My friend Ajay Bate, and he has used some 3 consultants, one from America, one from UK, and one from Europe, like that, to define what should be a good structure, because Infosys wanted some good architecture also, not just a box-like structure for a parking story building. It's a parking story building for Infosys. So they just built this building and they just used the architects and then used one of the architecture which they liked it very much. It's something looks like a bird's nest and all, but then it also such that it allows ventilation into the building and it also gives you the air into the building. In the daytime, you need not do any lighting into the building at all, except in the nighttime. And it also gives you the air flow into the building. So this is the beauty of the building. Right? Now you can see that one is a concave and one is a convex precast elements, which are fixed all around as a facade structure. That is a facade structure. To fix those elements into these precast beam elements and all, they have provided these supports for those concave and convex elements into that. They will come and get fixed over that. You can see these elements how they are coming out. Is a precast columns and the beams and then hollow core slabs are inside. And then you can see that all these protruding elements, whatever all are there, are meant for these elements to come and fix. One is a convex and one is a concave element goes in like that. The air flows into that, light goes inside, such that there is no lighting required in the daytime. It's a wonderful conceptual this thing. But then the beauty is how much struggle they made to make this particular element like this and then transport it, cast them, transport it, store them, and then erect them. But they wanted to do a beautiful structure, and then with precast, there's a beauty that we can do. Okay, probably with conventional, it is too difficult to do. I'm sure all of you will agree. But in precast, this is quite possible to do. Each individual element, they are getting them fixed over there like that. With wonderful precision, they have done that. And it is my whenever I see this building, I take a lot of pride. Yeah, what a beautiful precast structure, and beautiful facade that the Precast India infrastructure have built. It is the beauty of the structure. Right? Now, 11-story residential precast wall construction is built at Untitled, Hyderabad. I appreciate Telangana state government, and I also appreciate my friend C.A.PRASAD, who have convinced the GHMC, Greater Hyderabad Municipal Corporation, for adopting the technology free into that particular district where there are about 34 towers. We have built about conventional towers are built as well as monolithic construction is built as some structures and the precast is also built. We have wanted to demonstrate 3 technologies. Sorry? Right. So here the 3 different technologies are used at one location in Guddigal, Hyderabad. The conventional construction technology, monolithic construction technology, and the precast wall technology. This is how usually whenever they build a wall, they provide the sleeve, provide the reinforcement, they provide a shuttering for the windows, okay, and the ventilators like this, and then they provide the dowels, okay, and then they put it on the table of 4 meter by 5 meter table, right? And then these all these what we have done here is there are about only we have done the external walls as precast wall, load bearing precast walls, and then we provided a 6.2 meter hollow core slab on top of that. All the internal walls are built on top of a hollow core slab. They are all made with AAC blocks. But having done the external walls, okay, the external wall does not require any plastering or anything. Directly painting is done to that. Yeah, so there are about 14 blocks which are made of precast, and then they're beautifully built into that. And then the technology is demonstrated into for conventional, monolithic as well as precast. Okay, and then they are completed and they are handed over to the ground. Now, we have one wonderful developer by the name Puja Construction, who is a contractor come developer. Okay, they wanted a type of construction in such a way that they wanted to showcase the grooves also. They wanted to see the beauty of the grooves. So it is possible within the table, they have erected this particular thing with the grooves also, and they pour the concrete, lift it, you will get the grooves out of it. And this developer has a passion that he wanted landscape also to be shown in front of each apartment. It's a duplex type apartment. It's a 10-story building. It's a duplex type, which means about five duplex types, total becoming a 10-story and two basements down. Okay. Now, I will show you the next slide where you can see that, yes, even this is a precast element where we have given these slots like this. Within these slots, they will provide the flower pots. Flower pots of a huge one with a soil into that, they will place it there such that each apartment guy can enjoy. Each apartment can enjoy this particular beauty of the landscaping into this particular structure. So this is how the building is coming up. Okay, they are doing it right at the site itself. They have set up their yard. Okay, and then these are the precast for the landscaping purpose. We have done even the precast one. This cantilever beam, which is projecting from the wall, is taking the precast element, is simply supported onto that. Okay, and then the elements will come on top of it. Right? So you can see that yes, there are columns also at the bottom, and then there are walls into that. The elements are the proper structure is coming up like that in a beautiful form. We can look at it. This is how it is now. Already 1, 2, 3, just two more duplex forms is left over, whereby it will become totally a 10-story structure, but is a 5-story duplex structure, and the vision is fantastic. In Venda, I have built one industrial structure at Vijayawada, where government of Andhra Pradesh wanted all the footwear industry to be located at one location. So we have done here a 2-story precast column, 2-story precast column, where we have used some Growtech couplers. Growtech couplers are very typical connections for the columns, whereby they have only about 250 to 300 mm cast iron sleeves. The bottom rod will come into that particular portion by about 200 or 250 depending upon the diameter. Top bar will be threaded and grooves from that. And then there's no continuity between the bars, but then the grout which is poured into that is a high strength grout, which is giving the connectivity. Okay, we have tested them in the Vijayawada Siddhartha Engineering College laboratory in the presence of METEY Warangal process. And then we found that yes, the Growtech coupler is doing wonderful, and the rod is the particular rod is breaking, but not the grout. Grout has so much of additional grout and strength, adhesive strength, where we are pouring about 80 to 90 mm LPA grout into that particular portion. And so here we have done a 2-story precast column at one stretch of a size of about 750 to 900 by 400 in width. Okay, and then the beams will come and join at this juncture, and then we do this concreting at that particular point. That you can see that structure how it rises when it is completed, and then you can see that yes, there are hollow core slab of about 12 meters span. Hollow core slab 12 meters span. It is something like you can see that from here to here is a 36 meter by 12 meter span. There are no columns in between. But 36 meter by 12 meter span, there are no columns in between. And a 12-meter hollow core slab is going, and thereafter they corridor and then they. So it's the beauty of doing that particular structures in precast. And then one more structure that I will show you here is Sai Life Pharmaceutical Industry in Hyderabad. They have industries at Hyderabad as well as at Bidar. And then they wanted a building to be built, and inventor took the cost, and we have designed the building. You can see the shape of the building and into that. So what happened with this building is that this all the interiors when it looks at, it came exactly like that after the building is built. Okay, and we have built. See, these are the initial conceptual planning done by the architect, and it has turned out to be exactly like that. Okay, with a beautiful landscaping and all that. okay, into this. So what is that we have done? They already have certain buildings around, so they do not want a conventional and then dust and everything to come. So they wanted a precast building to come such that the least disturbance, least dust and pollution is causing in the site. So they wanted a building to be built within about 6 months, but we took 7 months because of some drainage and water table problems. It took 7 months, but we completed and handed over to them, and then they built the remaining structure. So what is our philosophy here with this? So we have gone for a 3-story precast column, leaving the openings wherever the beams are supposed to come and join. There are certain location 3-story precast columns. There are some location 2-story precast column. In some location there is only single-story column. Why is a single-story column when we have built a 3-story column? The single-story column is adapted where there is a cantilever beam is projecting out. You can see that yes, there is a single-story column, but then from inside there is a cantilever beam is projecting out. When a cantilever beam is projecting out, we wanted the column reinforcement to go through the cantilever beam. So we have provided the sleeves in the beam such that column reinforcement is projecting out into that. That's how we have provided the single-story column. Otherwise, where the other locations are there, beams are coming and joining with corbels and all. Okay, we have provided a 3-story column. All these are some steel framing which will help in during the transportation such that the elements are not breaking. Okay, and while erecting this precast beam, these frames are removed out, and then the concreting is done. Okay, into that, and then it is a monolithic structure. You can see that. You can also see that yes, we have done a 13-meter long RCC precast beam with the openings to be given to the beam where the industry wanted it, such that they can take the pipes and other things through the beam itself. So we have provided that below the neutral axis zone, we have provided the holes and then allowed the pipes and other MEP services to go through the beams. It's possible to do so. This all the hollow core slab is erected into that, and then the 3-story precast column, you can see 2-story like that. And then on one side we have about 7.5 meter precast beams, and then the other side we have a 12 meter long precast hollow core slab. We have only a peripheral beam. There are no internal beams. Okay, there are no internal beams, only the peripheral beams. And the hollow core slab is sitting like this with a 12 meter span. Right. So this is how the structure is built over there. You can see that, and after its completion, yes, it looks like this. Internally, also a beautiful structure, which is going to be like that. Recently, we have our PSI executive committee members have all visited Ahmedabad, where we wanted to conduct our next workshop at SCOM in Ahmedabad in the month of April 14 and 15. We have seen 2 precast companies in Gujarat, Ahmedabad. One is Urbanac, okay, Urbanac, and the other is PSP Precast. We're quite happy and heart-filled with happiness to see the quality of precast that they are doing in an amazing manner. Okay, and I can see this gentleman, Mr. Arjun. Okay, he's a late into the 20s, and he does not know anything about precast. So he started visualizing about it, gone through the internet, and got hold of the people, and then said, "Let me venture into this precast construction," and then set up this particular industry. And then he's already doing some wonderful structures around that. So what he has also done is the quality that he is ensuring in the factory is quite amazing. He is sieving the sand about 2 to 3 times and then using it such that there are no unwanted particles coming into the concrete. And then he was also telling me that he is using only Ultratech cement, only one brand, such that the color of the element is also maintained throughout the structure. Okay, that is one very important point that the precast companies have to take into account. If you take only one brand, only one color is being maintained to all the elements, such that later on you need not even paint also same colors of cement color can be seen into the structure. In abroad, they are not even painting the structure because concrete itself is robust. There's no need. Why do we do paint? Because our brick walls or AC block walls are not strong enough to resist the water. They absorb water. So we provide paint on top of the brick walls of the cement plaster surface, paint as a protection surface, such that the water will not enter into the brick wall. Okay, but when you are doing a precast concrete wall, there is no need of paint also because it is already a very impervious surface, right? So if you try to do it like that with only one color of the element to come into the wall, then as a PT we can avoid painting also later into that. Okay, so even the abroad also, the industry is going such a way that they are going, if at all they want inside, they are going with the wallpaper instead of paint. Okay, that is the way India will progress further. Wallpapers are also now being addressed to, because this is one of the structures that this Urbanic precast is doing it. Okay, it is a RCC frame structure with a hollow core slab, but some of the developer wanted to go with AAC block wall as a filler walls. They have allowed them into that, but they are doing a wonderful structure. You can see that there is no congestion or anything. A neatly managed site. In all precast structures, precast construction, you will see that the site is very neat. The site is very neat, and then it goes in a simple and smooth manner. And what this gentleman has done also is that to demonstrate precast construction technology, he has also done one PMAY housing being proposed by Gujarat Housing District. He has built one stilt plus 4-story structure within his precast yard and then demonstrated as yes, this is a precast structure. Come and see. Okay, so he is allowing our government officials to come and see that yes, I can deliver your structures with this precast construction technology as a beautiful demonstration of precast technology into the PMAY structures. And then hats off to this young gentleman who has provided that. Okay. Now there is another precast form that I have seen in Gujarat. Okay, that Ahmedabad, which is PSP precast. Okay, and PS Patel is a well-known contracting firm in Ahmedabad. They are known for their quality. I have come across so many people say, "Oh, PSP means quality." Okay, like we feel Godrej means there is a quality, right? There is a brand, there is a quality. So in the entire Ahmedabad, I'm quite amazed to see from number of people, engineers, consultants, and all government bodies, and yeah, PSP means quality. There's a very big good name that they have amassed into that, and then they built it. And I had an interaction with this gentleman. Who says that, sir, if you are a design consultant giving me a cement of 300 kilos, I will put 325 kilos. I said, why extra? Sir, just to ensure that my cubes will never fail. And throughout my life, my cubes have never failed. I take an extra precaution to provide 25 kilos more. Such that cubes are never failing. Okay, and then the concrete, even though delayed and a bit late, also they will not have any failures anywhere. That is the way that is ensuring quality. Quality means a lot to him. And then during the Corona period, he has taken a call to set up a precast firm. He has set up a very huge 2 precast sheds. So he thought of first of all building his own buildings and as well as later on the other building. But then in between, he said he has got a huge order for the infrastructure requirement. And then you can see all these precast footings he is doing inside, as well as precast wall panels, which he is doing inside in a big and remote way. He got the work from Mumbai, Ahmedabad Express Railway, that infrastructure works, he got it from LRT, and then he is doing it in a big way. What he thought of doing, he built it. Now he is doing it, first of all, delivering it for the infrastructure purpose in a big way. He says now this itself will take him for the next 10 to 15 years, his industry is going to be busy with this whole precast, which is auguring well for the precast industry. Okay, fantastic the way the precast is going. So we have seen overall that precast is delivering it into the building sector, into the industrial sector, pharmaceutical industries and other things. And we have also seen, for the PEB buildings, I have listed providing some of the slides here, that for the PEB buildings, what happens is usually around externally, they are providing a 3-meter brick wall. Thereafter, for the rest of the height of 10 meters, they are providing a galvalume sheeting there at the top there. But this galvalume sheeting, what is happening is its life period is only about 10 to 15 years. It is getting damaged and then it has to be replaced again. So now, what we are now the PEB industry is also coming up. Come on, we take care of the main columns and all that. The top roofing sheet is okay for us. Can you deliver the external walls with the precast walls? Yes, for Amazon company, Inventor, PSV Precast, and Kakinada have all delivered the external precast walls of a height of about 7 meters, 16 meters, 19 meters, like that external precast walls. Okay, of that much height. It's not like 19 meters means too much of that much height. Yeah, it is a 7 meter, thereafter 5 meter, or it is like a 7, 9, and the precast, and they are interconnected with the drawers. We have provided that. I missed in providing these particular slides here, but that's how the PEB structures externally. Now we are trying to provide the precast wall. But I have been to abroad, yeah, abroad, and then see that in the precast, the industrial sheds are made with the precast columns, and the trusses. Trusses are also made of concrete frames. Trusses are also made of precast concrete frames, and on top of that, yeah, they are providing hollow core slabs, and then providing the lighting frames wherever they are required. Okay, and that is also going in the direction. And soon India will take up, will try to go in that particular field also. I think I have come to the end of my presentation. I just given you a brief of how the precast buildings are coming up, and then thereafter the industrial structures, okay, and then the infrastructure, the various types of buildings, and the various types of elements that are being used. There are precast columns, precast beams, and the hollow core slab. And I thought of telling you something about hollow core slab. The reason why hollow core slab is why they make a hollow core inside is below the neutral axis, we don't require concrete for any strength, because below the neutral axis, what we require is only a tensile strength. So an idea has struck to the people that why not we remove concrete below the neutral axis? But again, the steel does require a protection from corrosion and other things. So they made certain holes inside in such a that bottom 35 mm concrete will be there, top 35 mm concrete will be there. The top 35 mm concrete will take care of the compression that is required at the top. The bottom 35 mm will take care of the cover required for the pre-stressing strands, and the webs that are there in between the hollow cores, whatever the web is being created, yeah, that will take care of the shear also. That will take care of the shear also. It is something like an I-beam, which you will look into. I'll take you down to that particular portion and just show you that hollow core slab, what it means by just a minute. Right. So if you just look at this particular portion, yeah, the top 35 mm portion is concrete, bottom 35 mm portion is concrete. Yeah, we have these pre-stressing strands, and then you can see that yes, it is a curve like this, top flange and the bottom flange. Top flange is taking care of compression, bottom flange is taking pre-stressing strand, is taking care of tension. Together, all together, it is an element. And all these elements are such that they are 1200 in width, 1200 in width, they are placed side by side. Okay, there is about 1190 mm at the bottom. At the top level, it is about 1190. At the bottom level, it is about 1197 mm. Sorry, 1140 at the top level, 1190 at the bottom level, 1140 at the level, 1197, and they are placed here. In between, in this junction also, we provide a small grout. We provide a high strength grout, non-strength grout. Okay, and we provide rods and continuity at the junction. And on top of that, we play another sort of structural topping, such that monolithicity is achieved, and then the diaphragm action is achieved through these particular slabs. So there is a purpose of hollow core slab, that where the concrete is not required because the neutral axis, this is being removed, and then the weight of the hollow core slab is reduced. Now, what happens to the hollow core slab? The hollow core slab is manufactured in such a way that there will be a 150-meter long bed. Some are 120 meters, some are 150-meter long bed. They pre-stress the wire, and then the machine goes from one end to the other, pouring concrete, and then this extruders will automatically make the pores inside of it. Okay, as soon as you go, the machine moves, even if you stand on top of that, it won't crush also. It won't get crushed. That's the beauty of the hollow core slab. Okay, and then What is the grade of these pre-stressing strands that they use? The grade of the pre-stressing strands that they use is about 1,850 Newton per mm square. It ranges from 1,770 to 1,850. What we are using today for reinforcement rods is 500 Newton per mm square. And in the market now they are also telling 550 beam, 550 Newton per mm square. Okay, but here it is about 3.5 times more than the pre-stressing wire. So you need to know a little bit about pre-stressing and then. So what is happening in this pre-stressing hollow core slab is that when these pre-stressed and then they pour hollow core slab, after the 10 strength, 50% strength, then they will try to release the strands. By releasing the strand, it will automatically raise from the bed. Okay, when you take a 6 meter long hollow core slab, cut it and lift it, you will see a camber at the bottom and then the camber at the top also. That means it is up by about 15 to 20 mm. It is up by 15 to 20 mm is a camber. So this camber helps us in controlling the deflection also. Okay, so deflection is a major problem. So it is already an upward camber. Upward camber means that total element is no more compression, it is no more in tension. So after you apply the loads and all that, it may try to flatten out. Sometimes it will go down, but maybe by about 10 or 15 when all the loads come. So there's a beautiful advantage of this element is all it always the element is in compression. It is never in tension. It is never in tension. Now, compared to a conventional slab, as soon as you remove the shuttering, it has an instantaneous deflection by about 10 to 15 mm, right? An instantaneous deflection. And over its life, it will keep on deflecting further as it ages. As it ages, the in situ slab will keep on deflecting. Okay, the deflection is such that it will go to our requirement of 30 to 50 mm, and after some 50 to what is crossing 50 to 70 years, yeah, you can go and measure the deflection and then say that it is time now for the people to vacate. But in this hollow core slab, it is never like that. Since the element is always in compression, then the pre-stressing will always try to go inside. It will never try to deflect down much. Okay, even though it deflects less, but it will try to go down. It will not go down like a cast and steel slab. That is the beauty of the slab. Okay, and it is always in compression. It will never deflect much, and it gives much more strength. But the concrete grade that they will use into this is M50 grade. M50 grade corresponding to the pre-stressing strand of about 1850 Newton per mm square. There's the same strand that they will use into single T slab and double T slabs also, or even the solid pre-stressing precast slabs also. All right. So with this, I come to an end of my presentation. You are most welcome to raise your questions. Okay, I'm here to answer part. Yeah, take the questions now. Dr. Prasad and Bhalu Sundarwal.
Yes, sir. Thank you for valuable.
Yeah. I was seeing some questions. Can I see the questions one by one?
Yeah.
I stop sharing this such that you can raise your this thing, or shall I keep this on?
Sir, Prasad Garu.
Yeah.
Sir, I think inventor Satyanarayana Garu is there.
Oh, okay.
Yeah, introduce him to that good entrepreneur, sir. At that age of about 65 or 70, still he is striving hard for promoting this precast engineering industry. Introduce him.
Right. It's my pleasure to introduce Satyanarayana Garu.
Yes, sir.
He is now he is a 70-year-old young man. I will say that at the 70 years age, he has the thought of setting up a precast factory. He's basically a chemical engineer. He has set up a wonderful factory at Kakinada. They are supplying a bacterial powder with a US FDA approval, where US FDA team comes every 2 years and inspect their factory and gives a good stamp of a good quality control stamp. Okay, and then his product goes into America, but this as a bacterial product into the American market and with an absolute good quality. And from that level of a high standardization, he thought, why not, with Amaravati capital is coming up, why not I set up a precast factory. He has Googled and then set up his own. After setting up almost nearing completion, he has come across me somewhere in the web and he called me. Since then, we are traveling together. I'm doing all the designs to him. Now he's 75 plus, 75 plus, I think, sir, 75, 78. And he has also set up one more factory at Hyderabad. Okay, that's where he has delivered the Untitled project of steel to press, parking press, 9 stories. Even the C.A.PRASAD pharmaceutical industry is delivered by them, and he is delivering a number of precast structures in Hyderabad. He has set up one more factory in Bhubaneswar, and then doing a wonderful structures for the Bhubaneswar Development Authority. Okay, so that is one more area of doing. Now he is also trying to set up in Pedapuram for the to meet the demands of Vizag, Kakinada, Rajahmundry, and around all those areas. Now, with this small introduction, I now invite Sachana Garu to give a bit of information about precast industry, how he has set up, and how he sees the future of precast industry. Sachana Garu, please. Sachana Garu. Sachana Garu, are you available? Can you unmute and
Unmute, sir.
unmute and
Shall we go for question and answer?
all right.
One moment, we'll wait, sir, because it's a great privilege to introduce Sajnana Garu to all our members, because at that age of about 70-75 years, still he is working for precast industry. Means we have to be very proud, and it is a great opportunity to introduce him to all the members.
Yeah, yeah, definitely. And we have to take a lot of inspiration from this great engineer who have set up this at this age and then doing wonders into that. Okay. Just a moment, I am calling him. I think he is busy on some other line. He tells he is busy on another line. We take the questions in the meantime. When he
Okay.
joins, we will look into.
Okay, sir.
Yes, sir, we are going.
Thanks.
I'll read the question.
The questions, please.
Yes, sir. This is question from Baran. What is the performance of structure at beam column junction during earthquake? What are the special precautions to be taken at beam column junctions?
I think from your side, Durga Prasad, it is a voice is not coming up properly. Sundarrao, can you take the question and explain? Because the voice is somewhat feeble. And
Yeah. I'll ask Durga Prasad to come out to my room, sir.
Yeah, please.
Yes, sir, I will try.
Right.
Yeah, actually, the question is from me only. What is the performance of structure at beam column joints during earthquakes? What are the special precautions to be taken at beam column joints?
Wonderful. Right. What happens in precast is that in abroad and all, they are going with some steel connections at the junctions with the steel angles or steel plates and all that. Okay, and I am not prescribing that type of connections in India because ours is a predominant in ethnic zone. Our industry has not risen to the reinforcement of the precast column an L bend into the junction, and then we see that the junction is concreted. So virtually what we are seeing is, unlike in a casting situ construction, what is happening at the junction, the same thing is happening in the precast also. It's a precast column with corbels, beam with the reinforcement projecting into the column junction is entering into the junction, and we are concreting it. Thereby, we are not doing any special consideration for junction. It is virtually the in situ situation which is happening into that, whereby it is seismically strong and robust.
Do we use any special admixture or adhesive for the beam column joint, sir?
Not necessarily, because now what happens here is, in this type of construction, the precast beam is coming. On top of that, the hollow core slab is going to come, okay, which is there. But initially what is happening there is, first of all, we are putting the precast beams or the column corbels, and then doing the junction grouting before the hollow core slab is coming. Because this beam is a inverted T-beam. Inverted T-beam. So up to the end of that inverted T-beam, we are first of all grouting it with that same M40 or M50 grade of concrete, whatever is coming there into that. And thereafter, we are placing a hollow core slab. Along with the hollow core slab, the structural topping concrete also will come and join the junction. So there is no necessity of any special grouts or anything into that. Now, the grouts that we are talking about, when you are talking about the precast walls, we have the sleeves. We have the sleeves. Into those sleeves, we are putting, if the concrete wall is made of, let us say, M30 grade concrete, but the sleeve, into the sleeves, we are providing an M40 non-strength grout. A higher strength grout is being placed in the wall sleeves, which is a connection between wall to wall, which is a connection between wall to wall. And the same manner in the column to column junction also, we are creating a higher grade. Suppose if the column is made of M40, we are going with M50 to M60 non-strength, high strength grout, such that it plays a bit wider role into that particular junction where a high strength grout is placed. But not at the junction of column and beams, where we are going to the normal strength grade of what we are supposed to be doing for the slabs and the beams.
Sir, thank you very much, sir.
Sir, one more question is, sir, from Sundarao, sir. What are the best softwares available for designing precast designs?
All right. There is no software required. See, just like what we are doing the cast into conventional structure, we do design the multi-story structures in the same manner, the same software. It is only at the junction we do the detailing carefully. There is no software specially required for precast. But then there is a software called Tekla. This Tekla software is only used for detailing purpose. Okay, Tekla software is used only for the detailing purpose. But unlike STAD or ETABS, whatever the softwares are there to design the multi-story structures, is the same software is used for the multi-story designs. It is only at the junctions we have to deal it in a different manner of how are we detailing it in a careful manner. That detailed presentation of the junctions between wall to wall and beam column junctions, I will show it in my next presentation to the same audience. Okay, that has to go in the next way, because all this cannot be absorbed by the people in one presentation.
Thank you so much, sir.
Okay, sir. One more question is from Pawan Krishna, our Kakinada Center member. What will be the cost variation of precast construction compared with conventional construction?
Good question. I told you already that in Duttigal area, Hyderabad, we have demonstrated the 3 technologies, and then we delivered all 3 of them at the same cost. What are those 3 technologies? Conventional construction, monolithic construction using aluminum formwork, and then the precast construction. All of them are delivered at the same time. Just a minute, Sachan Garu is online. Just a minute. Sachan Garu. Full avutara? Okay. మీద presentation ఇస్తున్నాను దాని లోపల ఉన్నారా మీరు? ఆల్రెడీ ఉన్నట్టుగా మా దగ్గర కనపడుతుంది. బాలన్స్ ఉన్నదా? I see you. Is it there? Are you there? Alright. Okay. సరే టైం పడుకోండి. Okay, join అవ్వండి. Because Balachandra is very particular that you must come on and speak for yeah. Balachandra is a consultant from Kakinada and ACCE chairman Kakinada. He knows you. He has met you also. వాళ్ళ కాకినాడ సెంటర్ నుంచి నేను వాళ్ళ ప్రజెంటేషన్ ఇస్తున్నాను ప్రీకాస్ట్ మీద. ఓకే, సో మీరు కూడా ఉంది కాస్త మీరు ప్రీకాస్ట్ గురించి కనుక చెప్తే how you have set up at DCH and all that, how you are going strong with the four companies. We are live on that. Now I'm answering the questions. I completed my presentation. If you can join me, it is good. Will you పంపించిన లింక్?
స్పీకర్ ఆన్ చేయండి సార్, అవకాశం ఉంటే ఆన్ చేసుకోవాలి.
సార్ లింక్ పెట్టాను, చూసారు సార్?
మరి లింక్ పెట్టారు కదా మీకు, చూసారు కదా మీరు? చూడండి, దాన్ని క్లిక్ చేయండి. చూడండి మీకు లింక్ వచ్చింది, చూసి క్లిక్ చేయండి. ఓకే,
స్పీకర్ లో వాయిస్ బాగానే ఉంది సార్ సార్ది.
And yeah, we are talking about the cost aspect. So if you are looking at the cost aspect, now see earlier precast was considered to be costlier because prior to GST introduction, cement GST was at 18%, precast GST was at 28%. Okay, చెప్పండి. మీకు వాట్సాప్ లో పంపించారు చూడండి.
నేను బాగు పెట్టాడని చెప్పు, చూసారు సార్?
ఏమండి చెప్పండి, ఎప్పటికే పంపించారా సార్కి?
నేను సార్ నెంబర్కి పెట్టా.
సార్ నెంబర్కి పెట్టారా? సార్ నేను ఇప్పుడు పంపిస్తాను.
నేను పెట్టింది సార్ ఆల్రెడీ చూసారు. హీ కెన్ జాయిన్ విత్ దట్ డైరెక్ట్లీ. రిక్వెస్ట్ కూడా పెట్టా.
మీ నంబర్ లేదు కదా సార్ దగ్గర, ఏదో నంబర్ లో వచ్చేస్తుంటుంది, అది చూసుంటారు. నేను పంపిస్తున్నాను సార్, నా నంబర్ నుంచి పంపుతాను మీకు. ఒక నిమిషం
సార్. సత్యనారాయణ గారికి నేను తెలుసు, మన సాయిల్ టెస్ట్ చేసాం పెద్దాపురం యూనిట్ కి.
జస్ట్ ఇప్పుడు మీకు పంపించాను చూడండి నంబర్ నుంచి. మీరు కనెక్ట్ అవ్వండి, దీని లోపలికి ఆన్సర్ చేసుకోండి. Right. So coming to the cost aspect, what we are doing is both conventional, monolithic, and this particular. So how did we achieve? It's only a question of numbers. Only a question of numbers. We were given about 14 precast towers, okay, and then there are about 14 monolithic towers, okay, for which the contractor have bought the formwork, and then there are about 14 listing. When you have some good number, the cost will come down to the same. Let's not talk about one individual building where precast is costing more. Okay, even for an individual building, what we are looking at is, if suppose there is a gated community of 50 buildings they want to build, let us say, precast. Now, all these 50 buildings, yeah, same time or a little bit 2 to 3 models can be built, and even at 10% less cost. Because there are certain numbers. When there are certain number, precast becomes cheaper. Okay, this is the ballpoint to figure where it can. In precast, what happens is, if you have a good number, even the cost will come down. Why is the cost coming down? Because of the formwork. formwork is a major thing because you are trying to use some tables or some hollow core slab beds which are already fixed there. Your formwork cost is about 10% of the cost in your civil construction. This 10% is saved. 10% is saved because you are using the same formwork. So that is the only difference why when using the when you have number of elements to be precasted, then the cost will come down. That is one good advantage in the precast.
Yes, sir. And there are 5 questions from Engineer Babu Mahesh, who is a cement and concrete expert, sir. I will ask the questions one by one.
Yeah.
He is a member from our Kakinada Center. First question is, what are the durability parameters taken into consideration in making precast concrete elements in the view of environmental loading consideration?
Wonderful. Now, durability is well explained in our IS 456 code. Basically, from durability aspects, what we will do is predominantly we will provide the cover requirements to the concrete elements. Okay, this is wonderfully put up in the table in IS 456 2000 for what is the requirement of cover for beams, columns, and slabs from durability requirement. And the IS code has also given the requirement in terms of the cement quantity to be used in terms of durability requirement. In terms of durability for a mild, moderate, severe, and very severe consideration, what should be the cement quantity that is to be used in the concrete mix as well as the cover requirement. So both these are followed in the precast structures also, and durability is achieved. And IS code has also given the requirement in terms of file. Okay, from the file requirement, it has also specified what is the cover requirement. So, in designing the structures, whether it is a conventional structure or a precast structure, these requirement in terms of fire as well as durability requirements, we have to provide it in the RCC elements and then design it and provide it. Okay, hope that question is answered.
Yes. The second question is there codal provisions for precast elements casting in the view of earthquake resistance?
Yes, precast code is 15916. 15916 2016 is a precast code. Right? IS 1343 is a pre-stressing code. Both these codes have to be used in terms of the designing of the precast element. What happens in the design of precast elements also is that progressive collapse failure is also to be taken into consideration. And then we have this IS 16700 tall building code is also there. Okay, that code also covers about precast structures. In addition to 15916 2016, the tall building code 16700 is also takes have the provisions for these tall buildings and the precast storage structures. When we said in the NCR, a 30-story building is built using the precast code, yes, both these codes are taken into consideration and design. Now we are doing a stilt plus 8-story precast structures in NCR region for DRDO. Okay, and here we have used the load-bearing precast walls. So what is the minimum wall thickness that we have provided is 160 thick. 160 thick is the minimum thickness of wall that you have to provide even for a 20-story structure, even a 30-story structure. Why is this minimum 160-story requirement is basically from the 2/5 resistance requirement prescribed in the code of NBC 2016 as well as our IS 456 2000. Right? So the IS 456 2000 code also specified what should be the minimum thickness of the members in terms of the fire resistance requirement. In terms of the fire resistance requirement. Suppose if you take the walls, yeah, 100 mm thick is okay for a 0.5 hour to 1 hour if fire resistance requirement. Beyond that, if you go, it also says 120 mm thick, 140 mm thick, 160 mm thick. and it also prescribes the percentage of reinforcement to be provided corresponding to the thickness of wall and the fire resistance requirement. So all these requirements have to be taken into consideration for designing the structures. Okay. Next question.
దుర్గా ప్రసాద్ గారు మ్యూట్ అయినట్టుంది మీ మైక్.
Please brief about jointing mortar and action against dynamic loading or horizontal forces.
Read the question again.
Yes, sir. Please brief about jointing mortar and action against dynamic loading or horizontal forces.
Right. Jointing basically comes in locations of column and beam, which I have already explained that the grade of concrete that we are going to use normally for columns and beams, same grade of concrete is being poured in the junction also. Being poured in the junction also is one this thing. And then in between the hollow core slabs, there is a gap of 40 mm at the top, and then there is a gap of 2 to 3 mm at the bottom. And this we are using a non-shrink grout of about minimum 30 mm grade. Okay, is the requirement, but we are providing about 40 to 50 Newton per mm square non-shrink grout being provided in between the hollow core slab joints. Now, the horizontal diaphragm action. Horizontal diaphragm action, when we are taking care of hollow core slabs are like simply supported one-way slabs. Simply supported one-way slab where the load will only go on the supported elements. Load will only go on the supported element. But then we have the 75 to 100 mm thick structural topping coming on the top. That structural topping coming on the top is joining all the elements together, all the hollow core slab elements together. And then we take what is the net area of the hollow core slab together plus structural topping as a, then we take the total concrete area to resist the horizontal diaphragm action. So with the analysis, we put that's the equivalent thickness of the hollow core slab plus the 75 mm thick together as one element of slab in the analysis part, which will take care of the diaphragm action in transferring the forces to the elements of beams and columns.
Yes, sir. The fourth question is rehabilitation and repair methodology for precast construction over a period of time.
Right. Rehabilitation and repair methodology. Now, predominantly what happens if you go for a load-bearing precast walls and all, they are pretty strong shear wall elements. They are like a shear wall elements also at the same time. They resist the earthquake force as well, compared to the RC frame construction of columns and beams. When we are taking RC frame of columns and beams, followed by hollow core slab, we depend upon the core area elements like around the lifts and staircases, whatever the shear walls are coming, we take those elements are the predominant lateral resisting elements, while the RC columns around will be taking predominantly the gravity forces, but from compatibility rule, we take the deflection and compatibility of these shear wall elements with column elements also. But in a load-bearing RCC wall element construction, what happens here is these elements are all like the shear wall elements. All these elements will take the lateral forces, with the result the deflection that is going to happen because of these RCC load-bearing elements is quite less compared to your RCC frame elements. So I strongly propose the load-bearing RCC wall elements which takes very less deflection into consideration and a strong lateral resisting elements into the construction. That does not mean RCC element are not like that, but then it requires another additional set of RCC shear walls, whereby around the lift and staircases we have to provide into the elements to take care of the lateral forces into that. I think I have answered the question.
Yes, sir. Thank you, sir.
Sir, one more question is, sir, is it recommended for individual house construction in the view of economical point of view?
Yeah, it is also recommended for individual construction, but the thing is, one building like that to make, the formwork required for that in the precast industry becomes a bit costlier. We have not come to that particular stage. Yeah, but slowly the industry will go to such a element like, yes, if you have a 300 square yard plot, yes, we have this type of building ready for you. You come and erect into your plot. But to make that happen, what happens is our roads must be a bit wider roads, whereby the truck will come with these elements, and then the mobile crane should stand and erect it. Okay. If it is something like a new colony, roads are wider and not much of obstruction of the buildings or the electrical wires, and all that is not there. It is quite easy to employ a crane and then erect this. But into an already established colony where we have electrical wires and all that is going, it is not possible to do so. But over a period of time, all these precast companies will come in such a way that yes, in your 200 square yard building, we have this type of building available for you. We can come and cut. It is something like, we are now buying a ready-made pant and shirt. Tomorrow, precast industry will grow to an extent whereby for a plot of your size, yes, they will make the buildings ready and elements ready such that it can be transported and erected into your site. But it is only a question of some more time. The industry will develop and come to that level.
Sir, next question is, sir, there is question
Excuse
from...
me, sir.
Yes, sir. Please, sir. Chandrasekhar.
This is Chandrasekhar, sir.
Yeah,
Good afternoon.
Good
Sir.
afternoon.
Sir, a great presentation. We are very enlightened by your speech and
Right.
throwing light on the precast constructions. Thank you so much, sir, first of all. And a small doubt, sir. When casting 3-floor height, triple height or double height columns, whenever the beam junction is coming, there is only reinforcement is visible without the concrete casting to accommodate the beam as well.
Yeah.
And is that rigid as the concrete while lifting and handling it through cranes and all?
Yes. Yes, absolutely.
Is that rigidity will not be there, sir? No, that is my doubt while lifting and casting in position.
Okay, by lifting and erecting position, your doubt is, will the cracks will develop around that particular portion around?
Where the beam is supposed to be rest on that.
Exactly. Yeah, it's a good question. Yeah, one should get that particular doubt. And then there is another important question someone have not raised. Okay, one IIT professor have raised this question. Okay, that also I will tell you today. Now, if you see the presentation that we have done, where the industry wanted is somewhat a sleeker column. So we have gone for a 400 wide and 750 longer columns. So in that slender column, there is a possibility if you don't lift it properly, balance it, then the concrete around that open portion will try to crack. So in order to see that it should not crack and all, you have seen that Sachin Garu has provided some steel angles around. Okay, it is his own invention. He has provided the steel angles tight enough such that at that element, for whatever the transportation and the erection process, the steel angle around is taking care of that particular strength, and it has not developed any cracks because of that particular portion. But I can also show some examples like Precast India infrastructure. They are made by 1 meter by 1 meter column, and then they have given a huge 1 meter gap where a 1 meter beam is coming and joining. They have not provided an angle also there. But then there is such a huge steel is there. they ensure to see that the bending is not coming around that particular portion. It is only a question of properly lifting it.
That's
Whereby, okay, is how you are lifting the element in such a way that at that junction it is not subjected to bending is the main criteria. So this we show it in the drawings. You better provide lift it around this portion in such a way that this portion does not get the thing. That lifting details also we show. And
yes.
then sometimes in the precast say we take care of it also. That here Sachan has taken care because these columns are made at Vijayawada and then shifted to Hyderabad. So he has taken an extra precaution in terms of providing an angle around that such that it is not damaged while it is being shifted to Hyderabad. Yeah.
Sir, that is what I thought. While erecting and keeping it in position, till it takes its true position in verticality or whatever, it should be supported by some angular frame and some struts like thing in between.
Yes. Yes.
I thought it, but is it possible? Is it in practical? They are doing it or not? I don't know.
Yes, that is what I have shown you in the Sai Life pharmaceutical structure, where you are seeing some angles around the column. You know,
Okay, okay.
okay, that is where for the slim columns. But it is also possible that
Ah,
without the provision of, see, he has also done some columns without even providing the steel frames also.
okay.
If you are able to transport it carefully and then lift the element in a particular manner, there is no need to provide even the steel columns also. No one will provide the steel angle frame and all. But
Mm.
here is some he has taken an extra precaution. Let the columns not develop crack. Let me provide it.
That may be the delicate area and sensitive portion.
Exactly.
It may be developing.
Exactly.
And one more doubt, sir. While casting the surfaces, almost the finished, whatever the joints are coming, those are looking like very finished and smooth. When it is jointed with some other element like beam or the horizontal member, the slab or whatever, will the bonding will be that effective as it is casted in situ? That
But very good doubt. Very good doubt raised by you. What happens is at the junction of the precast column and the beams, that surfaces which are coming in contact with the fresh concrete are
yes.
usually made rough.
That's what.
Usually made rough with some binding wire and all that. We try to provide some deep grooves in such a way. Now, with the beam, sometimes what happens when you are providing an end formwork, okay, they provide, there are certain retardants are available, formwork retardants. If you apply that particular thing, after you remove the shuttering, automatically you will get a rough surface. Okay, if that is not applied, they will take one small grinding machine, try to make some chiseling around that surface to see that the concrete bonds well. And in addition to that, they also provide this nitro bond from Phosrock or some other company, which is a bonding agent between the old concrete and new concrete.
Yes.
Okay, that is a must and required.
But is there any testing procedure after you have erected and well did the joints are made up properly and there is no pores at the junction and all? Will you be checking anything in multi-storied high-rise buildings and all?
Yes, these elements are also tested and proven, okay, at a number of locations in abroad as well as in India also. And CBRI Roorkee have done wonderful tests for all these. You can see on the CBRI Roorkee website the number of precast. They are doing a very good research on precast. Okay, column and beam junction they have done it, and while they have done it and they have tested it to a particular strength and it has not yielded, and then they have gone to the ultimate listing, then it has yielded at the beam junction in the beam only, but not in the column. Because the way we design and see is the yield point should occur in the beams, not in the
Yes.
column. So they have seen to it that yes, the way they have designed, put up a precast beam at the junction and then they applied the load. The yield point has exactly occurred only in the beam, not in the column junctions, and the junction has performed very well. Okay, the literature exists on the CBRI Roorkee site. You can go through that.
Okay, sir. Thank you, sir. Thank you so much.
Okay. Good.
Yes, sir. Yes, sir. SVM Chandrasekhar garu is a famous consulting engineering at Kakinada, sir. He is our MC member, managing committee member, and leading Grade Kakinada chapter, sir. Thank you, SVM garu, for your participation and raising good questions from Kakinada, sir. The next question is from T. Kadirwell. Can we make upper floors in precast on existing conventional frame structure?
It is not a good proposal to do it because the precast has to be thought of right from the beginning, from the foundation stage. Okay, doing something afterwards is not a big possibility. It is not good to do it. I don't suggest.
But one thing we can do, precast slabs can be laid.
Yes, yes.
Yeah.
You can go with, yes, I agree with Sundar's suggestion that, yeah, you can go with that in-situ column and beams, and then you can put your hollow core slab on top of it, no issues.
Yeah.
But then hollow core slab, whenever I say, you better have to consider a span of about 6 meters minimum.
Yeah.
Otherwise, it is not effectively used because its strength is more compared to cast stone slab. When the strength is more, you have to consider a minimum span of 6 meters. But then again, as I said, hollow core slab is a one-way slab. One-way slab. So the load will go only under the beams where it is resting. So you have to design the elements accordingly. Okay, but your building already might have been designed with a two-way slab distribution and all. Now we are thinking of hollow core slab. Let us design the beam in such a way that yes, this beam only will take the load, and you can avoid some columns and some beams also. When the hollow core slab is spanning, more span.
Yes, sir. There are two questions from YRS Rao. What is the present status of precast industry in Andhra Pradesh?
Sachin Garu has set up a big factory in Andhra Pradesh, and we have built one 6-story industrial structure in Vijayawada. Okay, and then there is one more building built by Preca for CRDA office building in Amravati place, and then they also built one precast structure, the PDT office on the main Vijayawada road, Vijayawada Gunturu road. But then thereafter, the government is not doing well, and then the precast is not picking up well in the government sector. But then Satyanagara has also done one precast structure for one commercial structure in Rajahmundry, right? So it is now the consultants and all who have to take this precast further in convincing the consultant, in convincing the customers to go ahead with precast construction, departing from conventional. Because in the beauty of precast is that now what prompted Satyanagaru to come into precast is one this thing that while he is putting the conventional construction and all, the beam is never straight, the column is never plumb. But in precast, the element is made perfectly plumb and you can erect it perfectly proper manner, such that your building is perfectly plumb right from bottom to the top vertically as well as horizontally. Also, the elements are straight elements. There won't be any because the shuttering is a bit difficult to control in the conventional construction, whereby the odd shapes are coming out and the beam walls are also going in an awkward mannerly into that. So precast is an answer for a upright construction in the verticality as well as in a horizontal manner to maintain the directions and the dimensions perfectly.
Okay, sir. One more question is, sir, from YRS Rao. How the electrical and plumbing fittings will be taken care? All these are externally we have to fit.
Very good question. Now, when I am proposing a load-bearing RCC wall construction, we are providing all the electrical conduits and electrical sockets that are required into the wall element itself and then pouring concrete. That means your building needs to be designed thoroughly, including your plumbing, electrical and all. For plumbing, I am also suggesting in the toilet walls, we are giving a recess in the wall for the plumbing pipes to go into that. Suppose if the wall is about 160 mm thick, in a particular location where the pipes are going to come, we are giving a recess by about 50 mm, such that these pipes can be fixed into that. Tomorrow, whenever maintenance comes, yeah, you can open that and then do it. And then you can provide a casing on top of the pipes if you don't want to see the pipes. But I have seen abroad in Switzerland and at other locations where precast buildings are built, they are allowing the pipes to be seen in the bathrooms. Somehow we have now got a uh, philosophy where the architects are trying to see that they're embedded in the brick wall, and then through the only tiles, through the only pipe taps are seen, but nothing else. But it's not a big deal. I strongly suggest plumbing pipes are outside, but electrical pipes can go inside the walls is one solution, which we are doing right away. Even for DRDO structure, which we are doing in Delhi, we have given a recess for in the toilets such that tomorrow the maintenance becomes easier for the plumbing pipes. But for the electrical conduits and all, we are putting it in the precast walls and then casting them. Only the location, the sockets where they are coming up, there is a recess given, socket box will go, and then the pipe wire will be taken out. Yes, they are all well designed into it. When we are talking about hollow core slab, top of the hollow core slab where structural topping is there, into that we are running the electrical conduits, and then we are drilling a hole through the hollow core slab to come down wherever the electrical lighting point is there, and with that we are fixing it into that. It's quite possible and easier to do it. We are doing it that way.
Okay, sir. There is a question from Balaji. How does precast technology play a key role in refinery and petrochemical projects where high level of static and dynamic loads are envisaged?
Two things here. In the refinery and other projects, yes, we did do some structures to them where there are not so many cutouts through the slabs and all. But then what happens through this refinery and all, sometimes they predominantly go for the cast and steel slab because tomorrow they want to run a pipe wherever they want to cut a core through that. So for them, predominantly the cast and steel slab is a good solution. But if they have a building where so many pipes are not required to go into that, yes, precast floor slabs, precast column and beam frame structure can be done, okay, and which can be made into a fire resistant and as well as a durability resistant structure also. Now, we're talking precast in such a way that it is not so much different from the conventional structures. We are giving the same connections. Let it be the wall and the slab connection or a wall and a beam connection. We are similarly giving the same connection at the junction, and which is robust enough in terms of the lateral force as well as the fire resistant structure. Yes, this can be done. So suppose I will tell you for one example, airport structure the airport structure in Goa. When we have proposed a hollow core slab, they said they better go for in-screw slab because there for them, what happens is the floor slab structure, they keep on changing it. Sometimes they provide a kiosk at one location, they provide a cafeteria at one location, whereby they want to go on draining the course through the cast and steel slab, if it is possible to that. But in a hollow core slab, you have to predetermine the course. You cannot provide it. So then they said finally, it is better they go with a conventional RCC slab and then they drill the course whenever they want. So similarly, into the refinery and other structures, if they have a predetermined holes for a particular building, yes, we can do that in a hollow core slab. Otherwise, they can go with a casting steel slab with a precast wall and a precast RCC column and a beam, which is good enough and strong enough. Next.
One more question is from Balaji, sir. Does it work precast construction for foundations in large industrial project?
Right. Yeah, you can make a precast footing also, not an issue. Precast footing also is not an issue, but we advise against it because the footing will have more weight. footing will have more weight. Suppose on the other hand, if you are talking in terms of a PEB frame will not have much loads. Yeah, you can make a precast footing there itself and then get the dowels out, whereby a steel plate and a steel column can be fixed easily. I also showed you the PS Patel company from PSP Precast are doing the precast footings also. It's quite possible to do. Where the precast footing does not go in terms of very much weight, yeah, you can do it, because otherwise the transportation of the precast footing will be costlier. So predominantly we say better footings are done cast in situ, whereby you need not transport such a heavy elements, okay, and only the columns and the walls can be transported, which have a lesser weight in terms of 5 to 6 ton weight, like that. Walls and all are 5 to 6 ton weight, not more than that. Okay, if they are of a length of about 6 meter and all. But in the footing, if you talk about a 4 meter by 4 meter, a 1 meter, then it's of a huge weight. Okay, we try to avoid that. But where it is very difficult, long places and all, we had Precast India infrastructure about 200 kilometers away from their factory. They have to take everything, precast footing, precast column, precast beam. They have made everything and transported because nothing is available there. It is possible to do, not impossible. Next.
Sir, there is question from SVL developer, sir. I hope he's from Kakinada. He may be builder, sir. In strength point of view, which is best? Precast versus conventional.
Sorry, say that again.
In strength point of view, which is best?
Which is best? Right. When you are talking about precast slabs, they are all made with M50 grade concrete. That means they are higher strength. And when we are talking about precast elements like columns and beams also, they are also usually made, if you talk about M30, we go for M40. Okay, the precast company, if the designer designs it for M40, they will go for M50, M60. The reason being is that they want to demold the element faster. They want to take out the precast element faster from the formwork, such a way that they can cast once again into the very next day. So they go for a higher strength element always, rather than the strength that we are going to give, because in the precast factory, the precast molds have to be released faster. So they go for a bit of higher strength grade than what we prescribe. Thereby, the strength is always higher in precast elements compared to the conventional cast in situ system. So precast is much stronger than in the conventional cast in situ system, is the philosophy that we adopt. Next.
Okay, sir. One more question is from Engineer Babu Mahesh. Which type of cement is using for precast elements, OPC or blended cements?
Yeah, predominantly we are going for the OPC cement. OPC with the microsilica is a type of cement. And do all of you know something about microsilica? Microsilica is a slag which comes from the steel factory, okay, and is blended into powder. GGBS is also one such type. Okay, what happens is with OPC, you can derive a concrete grade of maximum M45. Beyond M45, you have to use some sort of a blends like microsilica or some other product. Okay, microsilica or some other product you have to use to increase the strength. When you use microsilica, you can go up to about M100 strength. From M45, you can go up to about M100 strength. Okay, so that is also a type of blended cement, but blended cement in the sense what the factory is trying to sell, that is not being taken by the precast industry. Precast industry takes OPC. If they require, they add microsilica and then try to derive the strength by their own. Okay, but not the blended cement which is supplied by them. Sometimes they don't get the strength, so they don't depend on that. So they go with OPC and then they add their own or GGBS or microsilica to gain the strength faster.
Okay. Okay, sir. One of our senior member, Devata Shagar garu, requesting, sir, one more lecture comparing multi-story structures, precast structures, sir. Multi-storied precast structures. Is requesting, sir.
All right. In my next presentation, I will try to give something about I will try to give some examples of the building. Okay, how the building is designed, and then the multi-story buildings with the RCC frame structure, load-bearing wall structure, and what is the cost difference, and how we have adapted the joints into that, such that because in precast most of the people have doubts about joints. I shall also talk about how the joints are made. Okay, all these doubts will be cleared in the next 1 or 2 presentations to all of you. I think
Hello.
Yeah.
Hello, sir. I am Shamim Banu, Assistant Professor JNTU Kakinada.
Most welcome, Amma. Tell me.
Sir, I have a small doubt regarding curing process for precast elements.
Very good. So curing process, 2 things about hollow core slab. Now our inventor MD Sachanagaru has come. He can explain you about how hollow core slab is being cured and all. Okay. I shall tell you very briefly, then he will continue it further. Hollow core slab is such an element which I told you that it is a 120 to 150 meter long bed where the hollow core slab is casted, and it takes about 1.5 to 2 hours for the element to go from one side to the other. And beneath this bed, it is on a steel plate. Beneath this bed, they have coils where hot water will be flowing into that. Hot water will be flowing into that. So now, what is happening with the hot water going into the steam coming out of that? It will heat the bottommost steel plate. Why are we heating the plate? It is like a pressure cooker situation. In the pressure cooker, what is that you are doing? After you are trying to keep the whistle on the top, and the vacuum is and the pressure is built inside. With that built pressure, it cooks the rice. Similarly, when they are heating the bed from the bottom, and the top, they try to cover it with a tarpaulin cover, with a very thick tarpaulin cover. The heat will not be going outside, but the heat is coming from the bottom. Why are we doing this? Is we are trying to hasten the process of hardening of concrete. We're trying to hasten the process of concrete hardening. They try to see that it hardens in about 8 to 10 hours time. In about 8 to 10 hours time. While doing so, when it hardens up in about 8 to 10 hours time, then they will cut the elements. Okay, by the time in about 8 to 10 hours time, they ensure to see that it gains about 50 to 60% strength. When it gains 50% strength, then it is fit enough to cut and then cut it into pieces and lift and place it in the storage, in the stacking yard. Okay, that is the philosophy that they will adopt. That is the predominantly element for the precast hollow core slab. Now coming to the columns and the beams. Columns and beams, they go by the natural methods of curing is one process, and then they have a steel curing chamber. Steel curing chamber is there set up by the precast companies. They send these element wall panels and beams and slabs also into that. They do the steam curing that will automatically maintain the temperature. Okay, and whereby by maintaining the temperature, it also tells yes, this element have attained so much already. This curing is sufficient for this. Yes, you can take out that element. It automatically tells on the board that this element has attained its strength. The curing is sufficient, and they take out that. So with the steam curing chamber, it hardly requires 1 or 2 days, whereby they maintain a constant temperature, it gains the strength, the element comes out. Okay, so the steam curing chamber process is there. Our inventor MD Sachanagaru will throw more focus on that. He will answer that questions. Hope I have answered your question. Yeah.
Thank you, sir.
Right. Now we will invite our MD inventor Sachan Garu only, please.
We welcome, sir. Satyanarayana Garu.
Sachan Garu, you are there?
Hello. Good afternoon, distinguished engineers and interested people in the precast and wanting to know so many technical details. Let me clarify myself. I am not a civil engineer and I will not be, my answers will not be relating to your structural lateral load or compression loads, all those things. I will not be answering. If anything comes from my mouth, maybe you don't take it so very serious. Okay. Prasad Garu is the person who has to certify those kind of things. With respect to the recent, the Banu's question about the curing, and we, different type of elements will undergo a different kind of curing cycle. Predominantly, precast industry looks to how to hasten up their curing cycles so that your machinery utilization can become better. That's where, as Prasad Garu said, your hollow core beds will have a bottom heating cycle and they're all computer controlled, and once we start, we will have a ramp up time and maintenance of so much time at so and so temperature, and then cool down and keep it. And this process based on the, actually besides the heating down and environment, suppose in a summer you will have a hastening of the process by a couple of hours. In winter, maybe take a couple of hours more time. And hollow core slabs, we don't cut unless we get 30 plus strength, and which normally you can get in 8 to 16 hours based on the climatic conditions, windy nature, and those things. And as per hollow core slab is concerned, we basically use the dry mix, like water cement ratio ranging between 22 to 24%. So it's a compacted, vibrated, compacted. It's a dry one. So you don't, actually your curing will be much faster because it's compacted with high pressures and its bonding is taking place as per the mechanical pressures which is applied on those casting process. And in relation to the walls, again, the objective is how quickly I remove, you reuse my molds. Like Prasad Garu said, as a structural consultant, we may recommend M30 concrete, but because fellows will like to use higher grades, maybe M35, M40. Sometimes it's so critical, maybe a little bit go high. And all these mixes are designed, certified by a testing laboratory, which are to be testified and which will be followed as far as the mix design is concerned. And all the batch records and the recording, all computer control, all the printout, everything will all calibrated equipments are used. They'll be in this also the walls, basically the walls also will go through a circulation line where you will have a kind of people, all engineers will know the shelf dryers kind of a thing. Like a refrigerator having all cold shelves. Also in precast, we will have all hot shelves, like they will all be covered. And the self heat, it is evolving because of the exotherm of the hydration temperature of the cement, which comes up. And we don't allow the air to escape. So we hold that moisture, which is getting evaporated in the process of curing, so that it doesn't develop the cracks, and we will get the element out in 16 to 18 hours. We'll get M20 grade out of these things, and then you can easily demold, take it out, go up to M24, M25 grade. So focus of precast industry is to, ultimately everything is turning out to the business. What is the most efficient way? And I also heard, some of the engineers were having a query whether you can do the foundation footings and all those things. Yes, it can be done. It's the commercial aspect of this. In fact, we are doing pocket foundations for HPCL refinery pipeline racks, and which footing will be weighing about 25, 26 tons. And we are casting in near Vijayawada, and they are picking up to Vizag and using it. We are also casting a lot of pump foundations, which are heavy, and again the cable drains and all 20 ton plus. A lot of them are being casted. And we are also casting columns of 15, 16 meters, though they are very difficult to transport. But they want it, and they weigh about 24 tons. And you are using heavy crane. It's the need, whether you have to go for that or not. It's commercials, if you are talking about 7,000 crore project, and because of this is not there, the entire project is getting delayed. So this is where the cost is overall project cost. And if you are looking into any independent residential building, like, one developer or engineer was having a query whether it is multi-storied and all those things, which Prasad said he will come and take another question. My say on that is basically, with a conventional construction, the labor cost, the floor by floor, the labor cost goes up because the material has to go maybe 5% rate, 10% rate, whatever it is. In the precast, once you set up your crane and all those things, production remains the same cost, and the elements are carried through the crane, whether it is the first floor, second floor, 10th floor, 15th floor, the same crane. The crane capacities will vary. That is the only thing. My feeling is the multi-storied residential buildings will be a good option in precast rather than cast in situ. And also we are doing a project in HPCL Vizag, rough project, because there was a question on the refinery project and all those things. One is that the refinery project, we are doing the elements for pipe rack, including the pocket footings, columns and beams and those kind of things, the cable trenches and all. Then we are also doing a substation building. 4 stories, half of the building, five stories, half building. We are doing a substation. So we have 3 substation buildings within that complex we are doing. There also we are in like 15, 16 meter beams are there, about 5, 6 of them. Very heavy. They are being transported. There we have to use high capacity cranes, like 260 tons carrying capacity of the crane. And this again, a new dimension of the technology. There is nothing which cannot be done. Everything can be done. So whether at the end of the day, what is the commercial aspect of it? Time versus the cost and the speed as such. It is the time is the speed what it comes into the picture. And because obviously is the right thing. And I also heard so many doubts about the joint casting and this casting, that casting. And even if you are doing the conventional building, maybe as a non-civil engineer, so you have built up your beams are, you have made up to the wall, or your columns have come up on the top and some beams are made. Then the beams, you do the reinforcement and do it. And that, again, the column connection you are doing later. Prasad,
Okay.
even in cast in situ, the
Yeah.
columns and your top beam, and then also the slab connected, beam connected to the column. That's a new junction.
Exactly.
What we are doing is the same damn thing.
Same junction
that,
you are following.
Yeah, junction is the same.
Same.
Whether I have the rest of the beam precast or otherwise, like what your extension of the column with a precast beam you are doing, but on the column it's a junction what you are making.
Yeah.
So that is obviously the thing. There is nothing so very different. So you are all knowing that, concrete to concrete connection, and what are the implications of that connection, what are all the other so many construction chemicals which are available in case it's very old or anything like that. In the precast construction, simultaneously you are doing the work, a few days later you are also doing these things. And there are also columns sometimes the buildings which are left, and you do the column every 1 week, 10 days you are doing the recast, extension of the column. There also it is the same thing. So You don't need to have any doubt on those things. Like Professor said, these are all established methods. And a lot of multi-story buildings are being built. And precast, now we are coming, because we are coming to the precast in India now, because the manpower costs are going extremely high. Earlier, everybody was getting a mason or a helper or somebody else at a substantially lower price. They are now. And also the speed and cleanliness of this execution, and obviously the life of this building, because they are produced, the elements are produced under factory condition. The life of these buildings are supposed to be substantially higher. CBRI sometimes make a claim it can be 50 to 100% more life. It can give precast things. So this is my say. If anyone of our members have any doubt, to be specifically clarified, to be a non-civil engineer, you can ask.
సార్ మీరు ఒకసారి మీ కెమెరా ఆన్ చేయండి, జనాలు చూడండి.
That's what I'm asking, sir.
Sachin garu.
Yeah.
Sachin garu become a hero.
Yeah. Let us switch on the video. Yes.
Sir, you are real inspiration to all of us, sir. That's
Come
why
on. Thank you very
everybody
much, sir.
wants.
Thank you. So this is my face. I'm outside in a village. I'm trying waiting on the 4G.
Yeah.
Oh, thank you so much.
This is what I'm doing.
Thank you so much. You are in the village still attended to our call and give the address. Thank you so much.
This is the temple.
Oh yeah. Temple built by you for the village. I have come to that inauguration.
Yeah.
Wonderful.
Thank you very much, Satyananda garu.
Yes, I wish
Thank
to
you,
also
sir.
say.
I want to introduce you. I want to introduce you to all our members, sir.
Yes.
Yeah, that's why I requested C.A.PRASAD garu to connect you to the webinar, sir. Thank you very much, sir.
Thank you, sir. Thanks for your concern. Thanks for your initiative.
Yes, sir. We are eagerly waiting to see your Pedapuram unit to be operational at the shortest period, sir.
I don't know, sir, if it can happen in the near future because of the current situation, what we have in the, especially in the AP.
Yeah.
So as far as the construction is concerned, if there is a project, if there are going to be projects near, Kakinada and Rajahmundry, we are ready because our entire design is ready and everything is ready. But we are not, because any plant construction itself will take me 2-3 crores of rupees because it's all going to be mechanically, mostly automated facility, which has to operate like that.
Yes, sir.
So it depends on the volume of the project which are likely to come up. We don't mind setting up something and trying to see how best we can operate from that location.
Thank you very much, sir.
Sundarrao garu.
Yes, sir.
If there are any projects in Kakinada, Rajahmundry around, even Sachin garu can lead the requirement from Vijayawada itself.
Definitely.
Vijayawada plant.
Yeah. Definitely.
We have a lot of capacity in Vijayawada.
Yeah, because Vijayawada has a lot of capacity.
Yeah. Yes, sir.
Vijayawada has a lot of capacity. You can just transport the element there and direct it. Because in Rajahmundry, they have already built one commercial structure.
Yes, sir.
Yeah.
Okay.
South India.
So, South India shopping mall.
Yeah.
Okay, sir. Okay. Thank you very much, sir. Thank you very much. And I thank C.A.PRASAD garu. Sir, one moment, sir. There are some more questions.
Sir, one question left from Krishna Chaitanya, sir. Water leakage is common problem in precast structure. How to avoid water leakages?
By doing a very good construction, that's all.
Follow the construction method properly.
Yeah.
See, every technology or every construction has a specification. We have to meet that specification and do it properly. Do first thing right. Okay, there is no chance left out.
Yeah. Quality.
These joints and all, there are certain baker rods against which we provide and all. So all these connections and all, I will show it in my next presentation, where Sachin garu also will be there. There are no leakages we are seeing anywhere in the structure so far built by us. Okay, So it is only a question of strict quality control and specification that we have to follow corresponding to that construction technology that we are doing it. Okay? This
Yes.
is the main mantra.
Hello, sir. Good morning.
Yeah, go ahead.
Hello.
Yes, please.
This is Babu Mahesh, sir. Good morning.
Good morning.
Very good, wonderful presentation, sir. One more question is there. Is there any warranty and guarantee for precast elements in the in view of life cycle cost and all life of the structural?
If an RCC structure life is 100 years, this is also 100, more than 100 years. The reason
Okay.
what we are telling you is, in the precast elements, we always use very high strength grade concrete.
Yes, sir. Yes, sir. Yes, sir.
As I told you, if I am designing for M40, the precast industry will go for M50 because the element has to be released quickly from the mold.
Mm.
Okay? So there is always some higher strength.
Mm.
Right? And all these elements are also, whenever you're doing pre-stressing and all, they're all high strength grades. So durability wise, strength wise, they're pretty stronger. They will last longer and better than your cast in situ structure.
Mhm.
Okay?
What about the performance-based specifications towards the concrete, sir? I think in recent code there is a performance specifications are going to adapt from Euro norms.
Correct. That is yet to come into our this thing. See, tomorrow it will come in such a way that a consultant will say, these are the specifications according to which I have designed.
Mm.
Okay. And any consultant can say, yeah, this building is designed for these are the specifications, these are the codes, this is the specification. IS codes are followed like this, and these are the specification to be followed in construction. It is a consultant who is going to give everything. That will be followed in construction also.
Yes,
and
yes,
it will be
yes.
maintained. And the
Yes, sir.
PVT also will be done based on the performance specifications specified by the consultant.
Yes, sir. Yes, sir. That is exactly correct.
How does the consultant will specify? By talking to the client also.
Mm.
The client also, he has to tell them, sir, this is the code, this is the specification I am giving, this is how we should build. Any contractor who is going to come on board, he has to build it according to this only. Then only
Yes.
this is guaranteed like this.
In all the aspects of performance and durability specifications only.
Exactly. So far, the durability, fire requirement, everything is there in the code.
And
But we are not writing a particular performance specification for a particular structure. Now, in future, for every structure, consultant have to prescribe one specification. That will be the Bible for that project.
yes, sir. I think a lot of countries they are following the performance-based specifications in durability aspects like durability index, oxygen permeability test, and all, chloride diffusion coefficient, and all. They are adopting in their designs, but not in India presently. But I hope in future we are expecting the same thing happen in India only.
In the next revision to IS 456, okay, all these are going to come.
Yes, I have proposed this durability index parameters, sir, for BAS.
Very good, very good. Good.
I think you forgot me. We met in V.S. Siddhartha College, sir, during one international conference is there. Smart Sustainable Cities in 2016.
2017 maybe.
16 or 17.
Yeah.
So that time I am one of the speaker for that event, sir. I have given one presentation at Christian structures, behavior of RC framework structures under suspect notes. That time we met, sir, with Srinivas Rao garu, Chava Srinivas Rao garu. I think you know, head of the department.
Hi. Okay, very good. Nice to meet you again.
Nice to meet you, sir. Thank you so much.
Yes, sir. There is a address from Kalyan Sundaran, SC/PWD, Tamil Nadu, sir. A really wonderful presentation from a highly knowledgeable engineer.
Thank you, Sundaram Garu. Thank you very much. You liked the presentation. So happy, and we will give 2 more presentations to cover you the aspects of the joints, and somebody also asked you for the multi-story buildings. And as Sachan Garu has carried out this multi-story building at Dundigal, so we'll talk about all the drawings right from foundation stage, about the wall element, how we have developed the drawings, what are the analysis courses and all. But once we talk about one particular building, total precast design and execution, then you will have a clear picture of the whole building. Okay, next time we will do that.
Thank you, sir. I'm really, I really surprised to see such a person who is having both knowledge as well as the capacity to explain even a toughest concept in a very simple way, sir. Wonderful, wonderful, sir. You are blessed with such a capacity, sir. Thank you.
Thank you very much. It is my pleasure.
Thank you, sir. Thank you to Satyanarayan, sir, also. Thank you.
Yes,
Thank you, sir. Thank you.
Yes, Sachan is always our inspiration. All of you should get inspired. Right? He is 75 years younger.
Thank you, sir.
Even now, he will sit on the side from morning to evening. That is his strength.
Oh, excellent, sir. Excellent.
Fantastic.
Thank you, sir. Thank you. So can I take leave?
Yes, sir. Yes, sir. Yes, sir. Thank you.
Yes,
Sir.
Thank you.
Namaste, Sachin garu. Thank you very much for joining us.
Thank you, Kakinada.
Thank you. Bye-bye.
We pray God from our engineer fraternity to give strength, sir.
right.
Thank you very much, Durga. Thank you very much, C.A.PRASAD garu, for giving elaborate lecture on precast elements and precast construction. We are highly thankful to you for the excellent presentation, and we need at least two or three more lectures on this subject, including the design aspects and the construction procedures, and what is the care to be taken during erection and all these things. In the next lectures, we need your presentation, sir. Thank you very much. Thank you very much for your very patient presentation, and we are highly thankful to you, sir. Thank you.
Thank you.
Thank you, sir. Now the time for vote of thanks. I would like to thank ACCA President Vijay Kumar Kisan Sanap, President ACCA, Kacharla Rajkumar, Vice President South ACCA, Vijay Vishnumaya, T Secretary General ACCA, headquarter team and the supporting team in this program organization. I would like to thank Center's Chairman Engineer Banu Sundara Garu, Treasurer Nalam Bhaskar Garu and MC members Kakinada for your support. I would like to thank today's speaker C.A.PRASAD Garu, Director METEY Engineering Consultancy for his valuable time in spending his time for this webinar. I would like to thank other center members of ACCI. I would like to thank Pragati Engineering College Sorampalam for his student participation. I would like to thank engineer participants and other participants. I would like to thank Diksha and Anna Gowda from ACCI headquarters in this program organization. I would like to thank our members, young members, Sunit, Sairam and Jasmine for his contribution in this program organization. I would like to thank Dr. Balaji, ACCA from Visakhapatnam. Thank you, one and all. Thank you.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you all.
Thank you. Bye.
Well done, Prasad. Thank you.
Thank you, Nagu.
We are closing, sir. Thank you.